everyone, these are the two-way frequency tables guided notes. Let's get started. Have you ever wondered which of your friends has a curfew and which of your friends have to do chores at home? Have you ever wondered if there's an association between those who have curfews and those who have to do chores? Whether or not someone has a curfew and whether or not someone has chores is an example of categorical data. Categorical data is data that can be divided into groups. Another example of categorical data is if somebody is male or female and if they play an instrument or not. Give two more examples of categorical data that you could compare. So we're just thinking of data that can be divided into groups. So how about if somebody has a pet or not? Another example of categorical data could be eye color. Explain why we cannot use a scatter plot to look at associations between curfews and chores. Scatter plots use numerical data, and questions like curfews or chores is not numerical data. Categorical data can be analyzed in a two-way frequency table, which is a table that shows quantities of different categories or groups. Let's look at the two-way frequency table below. So this is an example of a two-way frequency table. A random survey was taken to collect the above data. The information in the table represents how many people belong to the following categories. For example, if you want to find out how many people said they have a curfew and chores, you will look under the curfew column and chores row and notice that they intersect at the number right here, 63. How many people said they have no curfew and no chores? So no curfew and no chores going across would be this number right there, 37. What does the number 25 represent? So here's 25. That's in the no curfew and chores column. So that is how many people have no curfew but do have chores. Notice that the total cells are empty. So we have these totals and those totals, and they're all empty. The total are for the rows, columns, and overall total. Complete the totals in the table. This total right here will be the sum of 63 and 25, and that is the total of how many people have chores. So I'm going to add 63 and 25, and that gives me 88. Now for the no chores total, I'm going to add 12 and 37, and that gives me 49. Now I'll have a curfew total, which is 63 plus 12, and that will be 75. And then I'll have a no curfew total, which will be 25 plus 37, which is 62. Then I'll have a totals, which I can get by either adding the columns or adding the rows. They will give me the same number. 88 plus 49 is 137, or 75 plus 62 is 137. How many total people said they have chores? So up here, total people is 88. How many total people said they have no chores? So no chores total is right here, 49. How many total people said they have a curfew? Curfew total is right there, 75. How many total people completed the survey? That's going to be your total right there, 137. The totals in the rows or columns are called the marginal frequencies. Now we're going to be working with this frequency table right here. The two-way frequency table below is comparing what two variables? So we're going to look at the labels. So we have passed and failed, and then studied, did not study. Notice that the table is not complete. We are going to complete the table using the given information. How can you calculate how many students did not study and pass the test? So did not study right here and pass would be this number right here. And if I know that the total is 36 and 30 studied and passed, then I know that 6 did not study and pass, because 30 plus that number is going to have to equal the total of 36. How can you calculate how many total students failed the test? So now we need to calculate the total students that failed. And it looks like I can do that using these two numbers right here. The total has to be 45. The number that passed is 36. So I can go 45 minus 36, which is 9, and that will give me how many students failed the test. How can you calculate how many students studied and failed the test? So we need studied and failed. So we need this number right here. I cannot use this row because I don't have enough information, but I can use this column. I know that this number right here plus 7 has to equal 9. So that must be 2 because 9 minus 7 equals 2. Complete the totals in the table. So going back up here, the total that studied is 30 plus 2, which is 32. And the total that did not study is 6 plus 7, which is 13. And I can always check my work. Is 32 plus 13 45? Yes, that helps me know that my calculations are correct. Let's create a two-way frequency table comparing male and female and whether or not they play an instrument. Label the rows and columns in the table. Does it matter if you put the gender variable in the rows or columns? The answer to that is no. So I can put male and female here, or I can put male and female here. It does not matter. So I put plays instrument and does not play instrument here on the top, and male and female here on the side. But again, it doesn't matter if you switch positions of those. We have the following information in order to complete our two-way frequency table. It says a total of 137 people were surveyed. So the total surveyed is going to be right here, the total totals. A total of 62 males were surveyed. So that's going to be the male total. So we'll put 62 there. 45 females play an instrument right here. 37 males do not play an instrument. So male and does not play will be right there. So that is the information that I know. Now it asks me, how many males play an instrument? So males playing an instrument would be this number right here. So I can figure that out by doing 62 minus 37, and that will give me what goes right here. 62 minus 37 will be 25 because this has to sum to 62. How many total females were surveyed? So the total females, I don't know, but I can look at my totals. I know 62 males were surveyed and a total of 137 people were surveyed. So 137 minus 62 will be 75. So there were 75 females surveyed. How many total people play an instrument? Let's see, total people playing an instrument is going to be this number right here. And that's going to be 25 plus 45, which is 70. I'm going to finish filling in this table. So 45 plus this number will have to be 75. So that must be 30. And then I can figure out this number by going 37 plus 30, which is 67. And you may start realizing there's various ways to figure out numbers sometimes. I could have gone 137 minus 70 as well. Practice. Create a two-way frequency table given the following information. So my variable is skis and does not ski. Again, it doesn't matter if I put that on the top or on the side. Variable snowboards and does not snowboard. So I have the variables on my frequency table. Now it says a total of 400 people were surveyed. So 400 people total, that's going to be down here, my total. So that will be 400. 158 people said they snowboard. So that's going to be over there at 158. 112 people said they don't ski nor snowboard. So does not ski over here and does not snowboard. So that's going to be this one right here. Does not ski and does not snowboard. 100 people said they ski and snowboard. So ski, snowboard is going to be right here. Now we got to look at the frequency table and figure out what numbers can I continue to figure out. For example, I can't figure out my totals down here yet. I don't have enough information. I could probably figure out this total because I know this is 158 and I know this is 400. So 400 minus 158 will give me 242. And because I know that, now I can figure out that does not snowboard but does ski. So 242 minus 112, that gives me 130. Now I can figure out my skis total. Summing 100 and 130 gives me 230. And I can figure out the people who snowboard but do not ski by doing 158 minus 100, and that's 58. And then I can sum up the people who do not ski to get my total. So 58 plus 112 is 170. Now let's answer the questions. How many snowboard but do not ski? Okay, so snowboard does not ski. That's going to be this one right here at 58. How many ski but do not snowboard? So ski, do not snowboard. That crosses right here, and that number is 130. How many total do not snowboard? So my does not snowboard total is 242. How many total people ski? Right here, 230. If you are wanting to find an association or correlation between two variables, you will need to create a two-way table showing relative frequencies. Relative frequency tables show ratios or percentages compared to the total. The data in a relative frequency table may be displayed as a fraction, decimal, or percent. To create a relative frequency table, consider the total of the table as 1 or 100% if you're using percents. Each cell is then calculated by calculating the ratio of this frequency compared to the total of the table. Complete the relative frequency table below and round to the nearest hundredth. So here is our frequency table already done for us, but now we're going to create a relative frequency table for the data. So the relative frequency is going to be compared to the total down here, which is 45. So we had 30 people that passed and studied. So that is 30 out of 45. So I take 30 and divide by 45 and I get 0.67. The number that failed and studied is 2 out of 45. So 2 divided by 45 is 0.04. Again, I'm doing my 45 from right there. The number of people that studied is 32, so 32 out of 45 is 0.71. And it's going to all be out of 45, which is my total. The number of people that did not study and pass right here is 6, so 6 out of 45. So I take 6 divided by 45, and I get 0.13. The number of people that did not study and failed is 7, so I take 7 divided by 45, and that gives me 0.16. Now the total people that did not study is 13, so 13 divided by 45, and that gives me 0.29. The total people that passed is 36, 36 divided by 45, and that gives me 0.8. The number of people that failed is 9, so 9 divided by 45, and that gives me 0.2. That is a relative frequency table. Using the data from a relative frequency table can be misleading. If you notice that the difference between those that studied and did not study who failed is only 3%, this does not seem like a very big difference. To accurately find associations in the data, you need to create a conditional relative frequency table based on either the rows or columns. Whether you decide to do a row or column conditional relative frequency table depends on the question. So on the previous page, we just kind of talked about what is a relative frequency table. This one, we did them all to the total. But to really get deep down into the data, we're going to do what's called a conditional relative frequency table, which is dependent on either the columns or the rows. Looking at the question, of those students who did not study, did more of them pass or fail? Since we are focusing on the variables pass or fail, we will create a column conditional relative frequency table. So yes, we're looking at the people who did not study, but the focus is, did they pass or fail? The pass and fail is in my columns. If you put it in your rows, then it would be the row conditional relative frequency table. But since it's in my columns, it's going to be the column conditional relative frequency table. In a column conditional relative frequency table, the columns will be 1 or 100%. So whatever you're focusing on, if it's the columns or the rows, that is what's going to be your whole. So complete the table below, round to the nearest hundredth. Here is my frequency table. Now my column conditional relative frequency table. I'm going to have my columns be the whole. Here, my whole is 36. So in this column, they're all going to be out of 36. Here, my whole is 9. So these are all going to be out of 9. So this one's done for us. 30 out of 36 is going to be 0.83. 2 out of 9 is 0.22. 6 out of 36. So 6 divided by 36 is 0.17, and that's rounded to the nearest hundredth. And then 36 out of 36 will give me 1. 2 out of 9 is 0.22, and then we have 7 out of 9 divided will be 0.78. And then 9 out of 9 is 1 whole. Let's revisit the questions. Of those students who did not study, did more of them pass or fail? Notice that 0.17 of the students who did not study passed. So let's look back here. 0.17 of the students who did not study passed. Okay? And blank of the students who did not study failed. So going back, so the people who did not study and failed is going to be 0.78. The difference between those two ratios is, so we're going to go 0.78 minus 0.17, and that gives me 0.61 or 61%. That percentage is much different than the 3% from the original relative frequency table. So if we flip back just to the relative one, we're looking at these two numbers right here. That's only 3%. But if we can create the conditional relative frequency table, that becomes a 61% difference. Since the difference in the ratios is large, you can say that there is an association shown in this data between those who did not study and passing or failing. Now let's look at the question of those who passed this test, did more study or not study? So we are looking at the variables of did more study or not study. Those are the two ones. And then, yes, it is talking about those who passed the test, but we're looking at if they did study or did not study. Since the variable we are focusing on now is studied and did not study, see how those are in the rows? We will create a row conditional relative frequency table. So my whole here is 32, and that comes from the table. And then my whole on the bottom is going to be 13, because that's the whole of that did not study table. So I'm going to have to flip back to get those numbers. So did not studied and passed will be 6. So 6 divided by 13, and that gives me 0.46. Did not studied and failed will be 7. And then so 7 divided by 13, and that gives me 0.54. The difference of those who passed and whether they studied or not is, so of those who passed and they studied or not. So we're comparing 0.94 and 0.46. So we will subtract to get that. And that equals 0.48. Though not huge, this is a large enough difference to say that there is an association between the data. The bigger the difference between the data, the stronger the association between the two variables. If the difference is small, then there is no association between the two variables. The variables would be called independent variables, meaning they do not affect each other. Practice. Create a row conditional relative frequency table with the following data to analyze the question of those who have curfews. Do more have chores or no chores? So we're looking at the variables, do they have chores or no chores? So chores and no chores. And that is why it is a row conditional frequency table, because the chores and no chores are in the rows. So my chores is out of 88. So that's going to be my total, 88 out of 88. And then my no chores is going to be out of 49, because that's my total there. 49 out of 49, and those are both equal 1. Chores and curfew is 63 out of my total of that row, which is 88. So 63 divided by 88 is 0.72. Chores and no curfew is 25 out of my row total, which is 88. So 25 divided by 88 is 0.28. No chores and curfew is 12 out of that row total, which is 49. So 12 divided by 49 is 0.24. And no chores and no curfew is 37 out of that row total, which is 49. So 37 divided by 49 is 0.76. And just notice that these will equal that whole there of 1. Determine the difference of those who have a curfew and whether or not they have chores. So have a curfew and whether or not they have chores. That's going to be these numbers right here. So we're comparing 0.72 and 0.24. So we can subtract to compare. So 0.72 minus 0.24, and that equals 0.48. Would you say there is an association between having a curfew and having chores or not? I would say 48% is a pretty big correlation, so we're going to say yes. The difference is 48%. This is a big enough difference to show an association. But since the difference is not like huge, we can say that the association exists, but maybe is not super strong. Okay, everybody, this is it for today. Thank you.